Hello there, students. Today we're going to be talking about how to solve quadratics by completing the square and by taking the square root. They're very similar to each other. This entire unit is dedicated to solving quadratics, and that means finding these points of where the parabola crosses the x-axis. They can be called x-intercepts, solutions, roots, or zeros. Those words are interchangeable when we're talking about solving quadratics. So be on the lookout when it's asking for the roots or the zeros or the solutions. Those all mean the same thing. Now, keep in mind, we can have two solutions. If the parabola is just sitting right on it, we could have one solution. And it is possible that we have no real solutions if the parabola is like above the x-axis or below and pointing down. There's no real solutions, but we are going to learn about imaginary solutions very soon. So those are what we're going to be focusing on today. It's helpful to know lots of different ways of how to be able to solve quadratics because sometimes one method may be faster or better than another method. The first method we've learned so far is by factoring, and factoring is the fastest method, so we always use that as our go-to method first. Today we're going to be learning how to solve by completing the square and taking the square root, which is a method that is not as efficient for the most case unless you have a certain kind of problem. Whenever you have a problem that's set up like this, I'm going to show you it is much easier to just take the square root and finish the problem off. The final method we're going to learn is by the quadratic formula, which will be our last lesson. And keep in mind that we can have one solution, two solution, or no real solutions for any of these solving methods. All right, so let's dive into what we're going to be learning today. Notice this problem, I have only an x squared. There's not another x here. And so it's easy to solve by just isolating that x like you would an algebra problem. So if I add 125 over here, I'm left with 5x squared equals 125 if I add 125 to the other side. Next, algebraically, you would divide by 5 because it is being multiplied right now. And you get 25. All right, so x squared equals 25. To last solve, to undo a square, we would take the square root of both sides. And now we know the square root of 25 is 5. But because we are solving equations, we know that -5 will also work. So you will always, when you take the square root in solving equations, you will always use the plus or minus. Think about the equation we were solving just above. I could plug in 5 here. 5 squared is 25. But -5 squared is also 25. So that's why whenever we take the square root when we're solving equations, always do plus or minus. So our equation is positive. Our solutions are positive and -5. All right, go ahead and try solving the next one algebraically. Pause the video and give it a try. All right, at this step, you should have gotten the square root of 16 is plus or minus 4. Don't forget the plus or minus here. It's very important. So your final step would be to subtract 1. And when we do that, we're going to get 2 answers because we have 4 minus the 1 is 3. But we also have -4 minus the 1, which is -5. So we're going to have 2 solutions in this instance. Okay, pause the video one last time and try the last problem out. All right, in this problem, we are down to x squared, or x equals the square root of 8. And don't forget, it again will be plus or minus because we could plug in the positive or negative version. And I want to go ahead and reduce this radical because 8 is not a perfect square. I can't take the square root of it. It would give me a decimal answer. And if this was a multiple choice test and it was giving you a decimal, you could put it in your calculator and get a decimal answer. If you don't have a calculator, you can reduce the radical by looking for the perfect square that could divide into 8. Well, I know that 4 is a perfect square that divides into 8 2 times. So when I reduce this radical, I take the square root of 4, which is 2, and this 2 has to stay inside the radical because it's not a perfect square. So we reduce the radical as much as we can, and that will be our final answer. Now, for our next section, I want you to notice that when you come across, like on the SAT test, a problem where it is not a perfect square, we can make an estimation. So, for example, if I look at this last example of the square root of 8, and I wanted to know approximately what decimal it would be between, I would look at the perfect squares. I know that 8 falls between 4 and 9 that are perfect squares. So I know my answer is going to be 2 point something. Between 2 and 3 is where it's going to fall, because 8 falls between 4 and 9. And it's actually closer to 9, so I know it's going to be closer to 3. So 2.8, 2.9, somewhere in there is where it's going to be for sure. So keep that in mind as we do our next problem. So again, I want to solve by approximating what the square root would be. We're trying to find the zeros, so I'm going to go ahead and plug in 0 for y. And then I'm going to solve algebraically just like we were doing. I'm going to subtract the 360, divide by -6, and -360 divided by -6 is just 60. All right, so I'm going to take the square root here, and this is not a perfect square. 60 is not a perfect square. But let's go back to our list and think about what would be the closest perfect square so we could get an approximation. So 5 squared is 25, 6 squared is 36, 7 squared is 49. We're not there yet. 8 squared is 64. Okay, now we're in the ballpark, right? We're trying to find where the square root of 60 is closest. Well, it is between 7 and 8 because it falls between these perfect squares. It's closer to 8. So we know that it's going to be between 7 and 8. If I'm looking at a multiple choice test, I could look and narrow down my options to be able to get a good estimate about where this answer would fall. Okay, the final thing I wanted to talk to you about in this video is how to solve by completing the square, because I cannot just take the square root of this problem. If I take the square root, that x is going to cause a problem. So I want to make it into a perfect square so I can take the square root like we did on the previous side. And we did complete the square in the last unit. If you remember, we used it to convert from standard form into vertex form. So hopefully these steps sound a little bit familiar to you as we dive into them. So the first thing I like to do is to put it into standard form. And you do not have to do this because you can complete the square of just this piece right here. I just do it so that it is consistent with what we did in the last unit to help you remember the steps. I'm hoping it jogs your memory. Okay, we want to make sure it's equal to 0 is my goal. And if we have an a value that's not 1, we're going to do something else. And I want to show you that in the next example. But notice our a value is 1 here, so I don't need to do anything extra. Okay, we are going to complete the square on these numbers right here. These numbers. That's the perfect square I'm going to make, okay? So right now, I'm going to leave a space here. That's what I want to make into a perfect square. And then I'm going to bring down the -20. Okay, so to make this into a perfect square, this is the b. I'm going to half it and square it. That's always the pattern. So half of 8 is 4, squared is 16. So I'm going to add 16 here. If I add 16 to this side, I need to subtract 16 here. So I'm keeping my equation balanced. I'm on the same side of the equal sign. So if I'm adding 16, I need to subtract 16 on the same side of the equal sign. If you're doing it on the other side of the equal sign, then you would add and add because you're on opposite sides of the equal sign. Whatever you need to do to keep your equation balanced is the key. Okay, so the perfect square that we just created was x minus 4, half of this number. I'm going to combine my like terms. right there, and bring everything down. Notice now I have a perfect square that I can take the square root of. So I'm going to continue solving for x. Now I'm going to add the 36 to the other side. Now I can take the square root of both sides. So I'm left with x minus 4 equals, and I'm taking the square root, so don't forget, plus or minus 6. When I take the square root of 36, it's plus or minus. Okay, so now I'm going to add 4 as my final step to both sides, which means I'm going to get 2 solutions because I have 6 plus 4 is 10, but I also have negative 6 plus 4, which is negative 2. So those would be the 2 solutions. All right, now the second scenario is a little bit different because notice this time we have a as not being equal to 1. And I cannot complete the square with a being something other than 1, so I need to force it to be 1. And so I'm going to take these first 2 terms, and I'm going to factor a 2 out of those first 2 terms so I can complete the square on it. So what I'm going to do is I'm going to factor out a 2, so I'm left with just x squared plus 6x. And I also notice that it's not equal to 0, and I would like it to be equal to 0 to be able to solve. So I'm going to minus the 40 over here. So when I minus 40, that's going to combine to be a negative 54 equals 0. Okay, so now I have a as 1 in my parentheses here, and I have it equal to 0. So that was my first goal. All right, next goal is I want to complete the square. I want to make this into a perfect square. So in order to do that, I need to take the 6, this is the b value, and I'm going to half it and square it. So half of 6 is 3, squared is 9. So in order to make this a perfect square, I need to add 9. And over here, if I add 9, I need to subtract 9. That way I'm keeping my equation balanced. On this side of the equal sign, I added 9 and subtract 9, so that really zeroes out to be nothing. I'm not really changing my equation. I'm just manipulating it to make it do what I want it to do. All right, so I brought the 2 down. The perfect square that I just created is x plus 3 squared. It's always half of this number right here. Combine like terms. So when I combine negative 9 and negative 54, that's negative 63. Okay, now continue solving for x. Okay, hold on. I just made a huge mistake, and I wonder if you caught me. And this is something that students do all the time, and so it's important that you see the mistake that I made. Notice here when I was balancing the equation, I subtracted 9 here. But I didn't add just 9 to my equation. I really added 18 to my equation. Because if I was going to distribute this out, 2 times 9 is 18. So in order to keep my equation balanced, what I really needed to do here was to subtract 18. Now I have a balanced equation. So I need to fix this number right here. Negative 72, it looks like. Now we're back on track. So it's important to don't make the same mistake I just made. All right, so now you should continue on solving for x. So you're adding 72 to both sides. You divided by 2 to get, oh, I don't know why I changed it to a 76. Sorry about that. That should be a 72. And then when you divide it by 2, that should be 36. And then we're going to take the square root of both sides to get x plus 3 equals plus or minus. Don't forget the plus or minus 6. And then we are going to subtract 3 from both of those numbers. So my 2 answers are going to be 6 minus 3 is 3, and negative 6 minus 3 is negative 9. So those will be our 2 solutions. the most common mistake is the one that I just made. So be sure that when you're balancing your equation, if you have an a value, you have to multiply it. We didn't have to multiply it here because 1 times 16 is still 16. So it keeps it balanced with not multiplying it. But when we have an a value, don't forget to multiply it out here so you don't make that mistake. Okay, pause the video. And I would like you to try a couple of these examples below, and I will show you the solutions as I work them out so that you can make sure that you're staying on track. So pause the video and work those 3 examples at the bottom, and then you can check your solutions. I hope you've given number 1 a try. I just wanted to note that you should have got to the square root of 26, which is not a perfect square. So you can't take the square root of it. You can try to reduce the radical, but there's not a perfect square that divides into 26. So in this case, when you are trying to just simplify your answer, we still need to subtract 2. So what you can do is you can still subtract 2, and you can just bring down the plus or minus square root of 26 and leave your answer that way. If you are given a calculator on the test, you can get a decimal approximation answer here, but this is a perfectly acceptable as well. Okay, example number 2. Let's see where you got stuck. So first, get it equal to 0, and then notice that a is not 1. So hopefully you factored a -3 out of the first 2 terms. Divide this by -3, and this by -3, and you're left with a +2. Now we're going to complete the square, so I'm going to take the 2 and half it, which is 1, and square it, which is 1. So to make this a perfect square, I added 1 here. Now, be careful. I really added -3 to this side of the equation, because if I distribute this out, -3 times 1 is -3. So to keep my equation balanced, I added 3. This was a -3, and this is a +3, so it balances out to be 0. Okay, so now we bring down the -3. The perfect square we created was x plus 1 squared. Combine the like terms. Now you're going to begin solving for x. So subtract the 93 and divide by -3. Take the square root of both sides. 31 is not a perfect square, nor can it be reduced. So go ahead and just write your answer like we did in the previous example. You'll have -1 plus or minus the square root of 31. Okay, give a try for the last example. You can do this one on your own now. You're ready for it. Okay, let's see how you did on this last example. Did you get 8 and -10? Let's see if we found out where you went wrong if you didn't get it correct. So again, you need to factor out the 2 to get a as 1. So I divided the first 2 terms by 2 to get this x squared and 2x. I also subtracted this 34 to get it equal to 0. So I got -160 here. I completed the square. I took the 2, halved it, was 1, squared it is 1. Notice I added 2 to my equation. So to keep it balanced, I subtracted 2 out here. When I combined those, I got -162. Brought down the 2. And this perfect square becomes x plus 1 squared. Now we solve for x, continuing on. So add the 162, divide by 2, square root both sides. Don't forget the square root of 81 is plus or minus 9. That's how you get your 2 answers, because when you subtract 1, 9 minus 1 is 8, and -9 minus 1 is -10. Great job. Make sure you practice all the practice problems so that you can do these on your own successfully. They just take a little practice and time. Good luck, guys.